Hey everyone, Mr. Fransky coming at you here. Hope that you enjoyed the story about our geometric series using the grains of rice. My guess is that we either didn't get to these examples or that we had to go through them pretty quickly, so I just wanted to make a video of them so you had a couple examples of how to use the formulas for geometric series, for finite geometric series. So let's take a look at what we've got here. They're giving us our geometric series, so we see we're adding these terms all together, so that's how we know it's a series. And what we want to know is see what kind of information we have here when we start off. So it looks like our first term is 4. So we have a g1, which is 4. And then we want to find our constant ratio. We want to see what we're multiplying by every time. Well, it looks like the first time we multiply by 3. Then we multiply by 3 again, because we see that square up there. Then multiply by 3 again, and multiply by 3 again. So it looks like our ratio is 3. We're multiplying by 3 every time. Last thing we need here is our n. And it looks like they want us to add up the first 5 terms. They actually give us the 5 terms, 1, 2, 3, 4, 5. But we haven't actually computed them. So we could do that. That's one way we could find S5. Because remember, S5 is the sum of the first 5 terms of this geometric series. Now, we could multiply these out, but it would actually take a little while, and especially if we were looking for like S20 or S30 or something, it would take a really long time to multiply all those and add them all together. So we can look at the two formulas that we have for calculating the finite geometric series. Now, the first formula, we talked about in class, how the two formulas are really identical. They're really exactly the same. The only difference is that we have 1 minus r on the top and bottom here, and over here we have r minus 1. The reason we have two different formulas, all we did here was multiply the top and bottom by -1 to be able to get this second formula. The reason we have to is because this one is really nice to use on the left here. If we have an r value, and we said absolute r because sometimes r is negative, if we have an r value that is less than 1, because if our r value is less than 1, then the top and bottom here are both going to be positive. If our r value is greater than 1, we tend to use the one over on the right here. Because if we have an r value that's greater than 1, I'll have, once again, a positive number on the top and a positive number on the bottom. So let's take a look at our series here. It looks like we have an r value that's equal to 3. Since we have an r value that's equal to 3, we're going to use this equation over here on the right. So to find S5, we're going to use this equation. And if you want to pause the video right now and give that a shot, just see if you can get that answer, that might not be a good idea. So go ahead and pause the video and try it yourself, and come back here in a minute. Okay, let's try this together. So we have our formula here. It's g1 times r to the n minus 1 over r minus 1. So we're trying to find S5, and we have all of our information on the left here. So g1 is 4. So just put a 4 up there. Multiplied by r to the n. So that's 3 to the 5th power. Minus 1, all divided by r minus 1, which in this case is 3 minus 1. So let's see if we can make that look a little nicer. So that's 4 times 3 to the 5th power is 243. Definitely grab a calculator for that if you needed to. Minus 1, and that's all divided by 2. Well, 4 divided by 2 is 2, so this is just 2 times 242. I believe that is 484, excuse me, 484. And that's our answer. So if we were to multiply these out and add them all together, we would get 484. And that's all there is to it. Let's try another one. So in this case, once again, we're given a geometric series, but it's a little bit different form. So here we're given sigma notation. We're given sigma notation. And what this is telling us is we want to add the first 6 terms together. So our n value here is 6. Our n is 6. And this right here, this is an explicit formula for a geometric series. So remember, an explicit formula looks like g1 multiplied by r to the n minus 1. And usually we say that that's equal to gn. Now in this case, we're using I, because I is what usually used for an index when we're looking at sigma notation. So here we're just using I minus 1 instead of n minus 1. That's no big deal. It's the same thing. So we have some information here that's given to us. So it looks like our g1 is 24. And it looks like our common ratio, what we're multiplying by every time, is 1/3. 1/3. And now we're looking for S6. We want to know what S6 is equal to, because they're saying they want us to add the first term. So plug 1 in here. That will give us the first term of 24. Then plug 2 in here. That will divide 24 by 3. Then plug 3 in here, 4, 5, and finally 6 is where we're going to stop. So once again, we have two choices for our equation, and see if you can remember which one we use. Which one are we going to use in this case? It depends on one of these numbers, and just take a second, look at these two equations, and see if you know which one we're going to use. So hopefully remember that we use this one on the left here when the absolute value of r is less than 1. We use the one on the right when absolute value of r is greater than 1. You can really use either one at any time, but it's just nice that everything stays positive if you choose to use this one when r is less than 1 and use this one when r is greater than 1. So let's take a look at our ratio. Our ratio here is 1/3. That's certainly less than 1, so we're going to be using this equation over here on the left. So if you'd like to pause the video right now and plug all these pieces in and see if you can get the sum for S6, you can go ahead and do that, and then come back, we'll try it together. All right, let's try this together. So we have S6 is equal to our first term, G1, which is 24, multiplied by 1 minus r to the n. So that's 1/3. It looks like we're finding n is 6. We're trying to find the first 6 terms added together. And that's all going to be divided by 1 minus r, which is 1 minus 1/3. Okay. So that's going to be 24 times 1 minus, I did this on a calculator a minute ago. Let me check that up. Looks like that's 1 minus 1 over 729. So this is 1 over 729. That must be 3 to the 6th power, 729. And that's going to be all over 1 minus 1/3 is 2/3. So I'm keeping things in fractions for now. You can keep it in fractions, or you can change it to decimal. It doesn't really matter to me. So that's going to be 24 times, so 1 is 729 over 729, so that's going to be 728 over 729. All divided by 2/3. And this is when I kind of got fed up with the fractions and changed them all to decimals in my calculator. So if you just grab your calculator and punch that in, you end up getting a total value of 35.95. 35.95. And if you chose to keep it in fractions, that ends up being 2,912 divided by 81. So either one of those answers is fine. Now, it is worth looking at and seeing if this makes sense. So where we're taking, our first term here is 24. Our second term is going to be 1/3 of 24, which is 8. So right away we'll be getting to 32. And then 1/3 of 8, that's a little less than 3. So that'll get us almost to 35. And then the next term will get us a little bit further. But it makes sense that the first 6 terms are going to be somewhere in the 30s. So I'd buy that, absolutely. I think that makes a lot of sense. Now, let's try one more. So this one's a little bit different. We're given a word problem here. So remember we talked about the viruses and the disease outbreak with the arithmetic series in lesson 8.4. Now let's see if we can do it with a geometric case. So here we're assuming that the first week there are 14 cases. So that's our first term is 14. And that each week thereafter the number of new infections increases by 25%. So our first week, let's say here n equals 1. So when n equals 1, we have 14 new cases. When n equals 2, our second week we're going to increase by 25%. So we could multiply by 25% and then add to 14. The quick way to do that is just do 14 multiplied by 1.25. Oh, we're multiplying here. It's looking like we might have a geometric sequence. So when n is 3, we're going to take that value and multiply by 1.25 again, which is just 14 times 1.25 squared. And it looks like this pattern is going to continue. So for the nth case, it's going to be 14 times 1.25 to the n minus 1, which is exactly the explicit formula for a geometric sequence. So what we have here, we know G1 is 14. We know our common ratio, looks like is 1.25. And then our n value here that we're looking for, we're just trying to use sigma notation to find the number of people infected by the nth week. So what we're looking for there is we just want to do a sigma. Starting at the first week, I equals 1. So we want to add all these together. We want to know not just how many new cases there are each week, we want to know the total number of infected people. So we're going to start at 1, and the first one, they just want us to go to n. So we're just going to go up to n. Of G1, which is 14, so I'm just going to put in my explicit formula here, times my ratio, 1.25, raised to the I. I have to use I minus 1 here because I is my index. I didn't use n here. And that is going to give me the number of people that are infected in the nth week. Now for the next one, they want me to actually calculate how many people have the disease by the end of the 5th week. So for that, I want to calculate S5. So Sorry, my S's look a little like 5s. So S5 is what I'm trying to find here. And once again, we have two equations. Hopefully they aren't covered up. We're okay. We have two equations we could use. And remember, we use one of them depending on what our R value is. So once again, see if you can figure out which of these two equations we're going to use, the one on the left or the one on the right. So hopefully remember that when the absolute value of R is less than 1, we're going to use this one on the left, because then we'll end up with positive values on the top and bottom. And we're going to use this one on the right when the absolute value of R is greater than 1. Well, our ratio here is 1.25, so we're probably going to use this one on the right. So S5 is going to be our first term, which we know is 14. So it's going to be 14 multiplied by our ratio taken to the nth power. So our ratio is 1.25 raised to the 5th power, because that's our n, minus 1, all divided by r minus 1, which is 1.25 minus 1. This is when you want to grab a calculator, because I wouldn't want to do 1.25 to the 5th. I guess you could think about that as a fraction. It'd be 5/4 to the 5th power. Wouldn't be too bad, but I grabbed a calculator for this one. So if you just plug it all in, you can do 1.25 to the 5th, subtract 1, multiply by 14, and then divide by 0.25. That's how I did it. That ends up equaling about 114.89. So about 115 people are infected after 5 weeks. So once again, you see you only start with 14 cases, but after only 5 weeks, we're up to 115. These geometric series grow very, very quickly. And that's all I've got for you on this video. So if you want to watch this a couple more times, if you need some more help with how to use these formulas, but remember that these formulas will be up on the sideboard for when you're taking your quiz on Monday. You just have to be able to figure out what the formula means. So you have to remember the big S, it means series. It means we're adding up all the terms. Other than that, you should be all set with these finite geometric series. And I look forward to seeing you in the next video for infinite geometric series. Talk to you soon. Hello again, everyone. Today we're going to talk about 8.7, which talks about infinite geometric series, or infinite series in general. And you might notice we skipped 8.6, which is just fine.